Welcome to 10.4 video lesson underneath Algebra 2. The concept here is the ellipse, and there are 7 boxes for us to talk about. So let's talk about the first one here, the ellipse. So what I'm going to do is I'm going to give you the definition and then talk about the definition inside the picture because it's kind of a lot. So here's the definition. The definition is the set of all of the points, x and y, in the coordinate plane such that the sum of the distance from each point to 2 fixed points called the foci or foci or the plural of focus, I'm not exactly sure how to pronounce it, is constant. Yikes. So what are they talking about here? So they're talking about this, okay? The picture itself, the shape right here that I'm outlining for you in black, the shape is the ellipse, okay? Now it's the set of all the points x and y. So every single point here, like this x and y, the sum of whose distance is fixed from 2 focal points that we have right down here. So this distance, this like D1 and this D2, it says the sum of that distance is a constant. And of course, there's a center as well. So that's the true definition of it. We're going to use this picture to help us get through all of the different aspects of an ellipse. But so the basic concept is that the ellipse is the shape that's made when you have 2 focal points. And basically, if you took a piece of string and you put 2 tacks on the wall and you took a piece of string and you pulled that string tight around with a pencil and then you drew the picture, you would end up with the shape of the ellipse. So that's what's going on with that right there. Okay, hopefully that makes some sense, and then we'll get some practice as we move on here. Okay, in box number 2, I'm going to explain to you all of the parts of an ellipse. So we're going to talk about each of these words that you see in green on the left-hand side. So first of all, the center of the ellipse, of course, is right where you think it would be. It is where the center of the ellipse takes place. That one's not too hard. The focal points, or the foci, there are 2 of them. That is the distance from the center all the way out to a focal point, okay? We're going to call that distance a value of c for right now. So that means that I can go back this way and come over here and I can call that distance a value of c for right now. Okay, so those are my 2 focal points. They lie inside the shape of the ellipse, and the distance from the center to a focal point is going to be c. So all we need is one of those, okay? The vertices, those are this point over here and this point over here. So I can call this vertex 1 and vertex number 2. And the distance from the center to a vertex, I'll do it in a different color for you. The center to vertex is what we're going to call A. The center to vertex is what we're going to call A. Center to focal point, we're going to call C. So those are my vertices, okay? And those lie on the graph. The major axis is the distance from, I'll do this in orange for you, is the distance from one vertex all the way to the other vertex. So that major axis, you'll notice, is a distance of 2a. So the distance here is equal to 2, whatever your a value is. So the distance all the way from one vertex to the other vertex, that is called your major axis. Sorry, that should be written here, 2a. Okay, that's your major axis. So now we got that one down. The minor axis is the distance from top to bottom. So top to bottom all the way from here to here, that is our minor axis. And the distance from one of these to the top of the minor axis, we're going to call a distance of b. Okay, we're going to call that a distance of b. Okay, so the minor axis or the coaxis. So the minor axis is the whole way. We're going to call the distance from the center to the top a value of b for right now. Okay, why are we doing all this? Because there is a relationship here, and the relationship says this. C squared is going to be a squared minus your b squared. So this is that constant that we were talking about earlier in box number 1. If I take that constant, a squared minus b squared, I get c squared, and that's the relationship between all of these values right here. So again, c is the distance from center to focal point. A is center to the one end of the major axis. B is center to one end of the minor axis. And the way this thing opens, it can be either up or down, or it can be left or right. Left or right. So in this case, this is going to be a left-right ellipse. The other case is where the major axis is more vertical. So these are all the things that we have to know about the ellipse in order to talk more about them. And the most important is these values for A, B, and C. So C again is center to focal point, A is center to vertex, B is center to top or bottom. Okay, number 3, box 3, the equations for the ellipse. There are 2 different sets of equations for the ellipse that we have to know. The first one is the equation for the ellipses that open up and down, and the second one is for the equations of the ellipses that are kind of left to right. So you'll notice that for an up-down ellipse, the length of the major axis is vertical, but for a left-right ellipse, the length of the major axis is horizontal. So we want to be careful of those 2 things, okay? So for an up-down ellipse on the left-hand side, our vertices are going to be top and bottom. Okay, our center is a center point. Our focal points are going to be along that major axis, and then our other 2 points will be on the sides. The equation that we get to use is this one right here, okay? X squared over B squared plus Y squared over A squared is equal to 1. Now, a lot of students don't understand how you figure out which one is which for the A and the B. The A, in this case, is always going to be the bigger one, and it's going to be under the major axis. So in this case, since the ellipse is an up-down ellipse, the A, which is the larger of the 2 values, has to be underneath the Y. Take a look at this one over here. If it's a left-right, my center will be here, my vertex will be over here, and my 2 focal points will be on the inside along that major axis. So here, the equation is going to be x squared over a squared plus y squared over b squared is 1. And again, a is larger than b, so the a is going to be on the major axis, so it's going to be a left-right ellipse. And in both cases, this still holds true. The c squared is equal to the a squared minus the b squared. So these are the 2 different equations that we're going to use for this section before we start moving it up, down, left, or right in terms of translating them. So for right now, every ellipse is going to be centered at the origin, and these are the 2 equations that we need. Okay, here's box number 4. We're going to walk you through an example, and hopefully this will make a lot of sense to you once you see me do it, okay? It says, write the equation for an ellipse that's centered at the origin, and one vertex is at -6, 0, and a co-vertex is at 0, 3. So a co-vertex is just that distance from the center to that B distance right there. So I suggest that you guys make a graph right away, because the graph is going to give you a lot of information. So one vertex is at -6, 0. So 1, 2, 3, 4, 5, 6, 0. Perfect. And a co-vertex is at 0, 3. 1, 2, and 3. Okay, so right away, I know that this is going to be a left-right ellipse because the longer axis is left and right. It means it's parallel to the x-axis here. So I know that another vertex has to be on this side, over here, and another co-vertex has to be here, on that side right there. So this is the picture that I'm going for the ellipse, and they're really hard to draw. And again, okay, my center is here. The distance from here to a vertex is going to be a value of a, and the distance from the center to a co-vertex or high point is going to be a value of b. So I'm going to have an x squared over an a squared plus a y squared over a b squared is equal to 1. And the reason I know it's this one, the a is going to be underneath the x, because my major axis is horizontal. So now I just plug in and go. So I'd have x squared over 6 squared plus y squared over 3 squared is equal to 1. And it's more customary to write it as x squared over 36 plus y squared over 9 is equal to 1. And I have now written the equation for the ellipse that's centered at the origin, and my major vertex is at -6, 0, and a co-vertex is at 0, 3. I think the best way to do it, you guys, is to draw a picture and then pick the right equation and then substitute in for your math. Okay, box number 5. This is going to be a you try. I want you to tell me the equation for the following ellipse. So take a look at it, okay? Is this an up-down ellipse, or is this a left-right ellipse? Okay, try and figure out the values of A and B and plug them in. Okay, hopefully you got the right answer of y squared over 25 plus x squared over 9 is equal to 1. If you didn't, let me just talk you through it really quick here, okay? This is an up-down ellipse because the major axis is parallel to the y-axis. So I now know that the A value is going to be underneath the y, okay? And then I figure out, okay, the A is the distance from center to one of my vertex, which is 5. The B value is the distance from the center to the co-vertex, which in case is 3. So I plug in and I get y squared over 25 plus x squared over 9 is equal to 1. Okay, box number 6 says, what are the foci of the ellipse with the equation 25x squared plus 9y squared equals 225? And then says graph the ellipse and then display all the important parts. Okay, so if I start by saying, okay, 225 x squared plus 9y squared equals 225. To make it look like in standard form, I need to get a 1 on the right-hand side, so I divide by 225, each piece, 225, divide by 225, okay? 25 divided by 225 is 1/9 as a fraction, so I'm going to have x squared over 9, plus, and then 9 divided by 225 is 1/25, so I'd have y squared over 25 is equal to 1. Now, okay, so now because the 25 is bigger than 9, it's underneath the y, I know that this is going to be a left-right ellipse, so it's going to look something like this. So I know that this is 1, 2, 3, 4, and 5, so I know a vertex is there. 1, 2, 3, 4, and 5, I know a vertex is there. Because the a squared value is 25, a has got to be plus or minus the 5. Okay, that means the b squared value is 9, so b's got to be plus or minus 3. So we go up 1, 2, 3, and down 1, 2, 3. So that point is there, and that point is there. Okay, so I'm doing pretty good so far. All I have to do now is figure out where the equation of the focal points are. And remember, c squared is equal to a squared minus b squared. That's the relationship because it's always constant. So therefore, c squared has to be 25 minus my 9 value there. And then so that means that c squared is going to have to be the number 16. So c is going to be plus or minus 4. So if I go 1, 2, 3, 4, that's a focal point, and back 1, 2, 3, 4, that's a focal point. That's vertex 1, that's vertex 2, and those are my co-vertices right there. That's how you would graph it and display all the important information. Okay, box 7, last one. This is a U-try. What is the standard form of the following ellipse? So take a look at it and see if you can figure out what all the pieces are and put it together. Okay, hopefully you got the right answer of x squared over 64 plus y squared over 39 is equal to 1. If you did not, let me show you how to do it. So right now, if I go from center all the way to a vertex, I get a value of 8. So the a value is going to be 8. If I go from center to the top of the co-vertex, I can't really tell what the b is. It's like a little bit more than 6. But I can clearly see that the center to a focal point is worth 5. So I know the relationship between c squared is equal to a squared minus b squared. So I plug in my values. I don't know what b squared is. I solve and I get b squared is equal to 39. So if I take the square root of 39, it's like 6.245. So that's where that point is right up there. Then I just plug in my values, right? And I know that this is a left-right ellipse. So I have x squared over a squared plus y squared over b squared is equal to 1. And therefore I plug in and I get my answer. Hopefully that makes sense to you guys, and I will see you in class tomorrow.